All right, question 9 now. Write a multivariate model to test the difference in standardized reading scores between small and regular classes. Awesome. Okay, so I'm going to go to my multivariate variable. So if I can do this, so here's the slow way to do it. If I do insert equation, I can do that. Or I can do Alt-N, then let go, push the letter E, then I, and it's right there, so I can get really fast. So I want to look at reading scores. So reading equals, now I have my beta naught, which is my intercept, or what I think of as my average reading scores when everything is 0, plus, okay, I'm going to add a beta 1. Now again, the question is between small and regular classes. So I'm going to have this be small. Beta 2, I'm going to have regular plus aid. So the reason I do this is because I want, when small is 0 and regular is 0, I want that to be beta naught, which is my regular class size. All right, so beta naught here, just interpreting it, is going to be the average reading score of a student in a regular size classroom. Beta 1 is going to be the average reading score of a small classroom compared to a regular classroom. And beta 2 is going to be the average reading score of a regular classroom plus aid compared to a regular classroom. So that's that. I want to add some other control variables. So I'm going to add gender, what we think of as a dummy variable for being female. I'm going to add another one for being on free lunch. Okay. I'm going to add another. Come in. You're making the 2500 video.
Sweet.
Okay, so he's going to turn something in. We'll get back to the video. Awesome. Thanks, Brandon.
Sweet. Do you need a copy of the Excel worksheet?
I don't right now.
Okay, cool.
All right, that's Brandon. He's in a class. All right. He's just
the video for the worksheet?
This for the class.
Oh,
Yeah,
nice.
it's pretty exciting. He's going to watch it later and see himself on video. Awesome. Thanks, Brandon. All right, so I'm going to add another beta 5 for white and one more beta 6 for black. And so if you're not white, you're not black, it's the other race. That's the omitted group. All right, and I think that's going to be enough variables, so now I'll add my U. So there's my model. Okay, interpret the coefficient on gender. Okay, so we haven't estimated anything. I'm just going to interpret the coefficient. So let's highlight this, put it into red. The coefficient is beta 3, and it's interpreted as the change in reading score of a female compared to a male. Controlling for class size, free lunch, and race, or controlling for the other variables. All right, so that's how we interpret gender. So what if females and males get the exact same score? Well, then we should expect beta 3 to be 0. If females do better, we should expect beta 3 to be positive. If we expect males to do better, then beta 3 should be negative. All right, and now for these next questions, we need to now estimate the model and go from there. So let's go to our data. Okay, sheet 1. It's right here. Okay, now I've done a lot of crazy things to this sheet. So I'm going to go back to AV and sort it from there. Oops, I didn't hit the right button. So let's go data sort. Let's delete the level and let's just sort by the number 1. Okay, so now everything should be back normal. And now we need to set up our regression. Okay, so the key here is we want to, let's set it up over here. So I'm just going to insert some columns here. So I want my first column to be their reading score, standardized reading score. Okay, so here we go. I cut that, paste it over here. So that's my outcome. Okay, my control variables, I need to have small and regular. Or small. And regular plus aid, not just regular, but regular plus aid. Let's go get that regular plus 8 one. Okay, and then I need to get my dummy variable for female and for free lunch. Okay, there's the female. Okay, let's go find that one for free lunch. There it is. And then one for white and one for black, and we are ready to roll. These are nice, right next to each other. Slide on over here. Put those in. All right, now let's run that data analysis. We're now going to run a regression. Our Y range is our reading scores. Okay, our X range are these right here. Shift down. I included the label, so we click OK. Non-numerical values. So that sucks, first of all. Second of all, it's something we can take care of. So let's go back to sort our data. And now we're not going to sort by Z1, but we're going to or by 1, we're going to sort by reading score. Click OK. So now here's our reading score. And so we just change our data analysis, regression, and we don't want to go to the 6326. So we want to go down. And we want it to go to, there it is. Oh, snap. To 5790. Okay, so it's going to go from D1 to 5790. That's going to go from E1 to J5790. Include labels, click OK. And now we have our regression. Awesome. Feeling much happier now. So let's kind of change these. Let's go. Just make them a little smaller. So we're going to try to interpret them a little better. There we go. Awesome. So I can copy and paste this. I'm just going to copy and paste this part here. Okay. So I'm going to just put that right beneath here so I can see where it's at. There we go. Okay, so do students on free lunch do the same as students who are not on free lunch? Well, controlling for everything else, students on free lunch score 0.47 standard deviations below students who are not on free lunch. And that T statistic is 16, so it's really significant. So our conclusion here, explain, is students on free lunch score about 0.47 standard deviations worse, controlling for class size, gender, and race. Okay, but now we also need to make a note, this coefficient is statistically significant. All right, and that's what we can conclude on that. Next, do white students do better or worse than black students? So again, the thing to note here is the default hypothesis is that this number is 0. So here we're testing if this is 0, meaning there's no difference between the two. All right, so we have to switch this up just a little because the test here will ask is do whites do better or worse than black students? So what this tells us is that whites do better, but not statistically different than non-whites, and blacks do slightly worse, but not statistically different than non-whites. But we don't know compare the two, so we need to come back to sheet 1, and instead of having the variable black, we're going to put in the variable other race, and that way our omitted group is going to be black. Okay, so let's rerun this. Oops. And we want to go through J, so we're okay there. Here's the new one that we did. Okay, what you'll find is that the free lunch variable doesn't change. Okay, all that changed was really how we're going to look at this. So white students do 0.139 standard deviations better than black students, and that number is statistically significant. So we're going to copy this, come back here. So sometimes you do run the wrong model and you just have to correct for it. So we're going to delete that table. We're going to leave the lines. No, we're not. Just go there, paste that, there we go. So white students score 0.14 standard deviations higher on reading scores than black students, controlling for class size, gender, and free lunch. This is statistically different than 0. Okay, but the question then is that an unbiased estimate? Well, one thing we want to think about is, are there other reasons that might affect a student being black as well as might affect their reading score? So it might be parental education, it might be other things, so it's not so much the race, but other factors that are correlated with race as well as with reading scores. Now the final kicker is, do small classes help? Well, being in a small class increases your reading scores by 0.18 of a standard deviation compared to a regular class, and that number is statistically significant. So let's look back here. What we found is that just doing a t-test between the means is 0.18, and now that we do a regression analysis, it's also 0.18. And the reason why those numbers are the same is because we have random assignment. The students are randomly assigned to classes. If we didn't have random assignment, those numbers would be different. So confirming what we found in our t-test comparisons, students in a small class do significantly better on reading scores than students in a regular class. Now we can add this controlling for gender, race, and free lunch. And therefore, that's where we get our conclusion now. Okay, but now if we wanted to go one step further, is do the students in a regular size class with an aid do any better? And we see that it's a regular aid. They get 0.035, so 0.035 standard deviations higher than a regular class, but that number is not statistically different than 0. So having an aid in class does not significantly raise test scores for reading.